Today I want to tell you about designing electric substations for the future. My name is Terry Hummel. I work at Nashville Electric Service in the substation design section. There we use Autodesk Inventor Professional along with Substation Design Suite or SDS. SDS was created by Automation Force as an add-in for Inventor that deals specifically with substation design tools. The first thing that we will discuss is electric utility challenges. And I want to show you how Autodesk Inventor compares with AutoCAD. Then we'll end up by looking at some of the tools in SDS. Electric utilities face the same challenges whether you're a small utility like NES, we're public owned, we don't generate any power, or a large utility that generates their own power and is private owned. One of the biggest ones for NES is a continuation of errors. We have carried these errors throughout the years. Another one is our aging infrastructure. More and more we're having to install equipment such as breakers and switches in locations that were not designed for them. And there's collaboration and consistency. Most of the time, we're not sure what the right hand is doing compared to the left hand. And there's knowledge capture. This is one of the biggest reasons that we needed to find a new product and Inventor worked for us, because once we enter the information about our parts, it's done. We don't have to do that anymore, and it is what it is. So these four areas are the biggest reasons that we went to Inventor Professional and then added on SDS. Now to compare Autodesk Inventor with AutoCAD. There's almost no comparison. Inventor can do so much more, as I'm going to show you. One of the biggest things is auto limits and switch simulation. With Inventor, we can set our auto limits to check phase-to-phase clearances or phase to ground, as you see here. And in this video, we can show the operation of a switch through its arc, and we can also set it to show it incrementally, which is very handy for checking clearances. Stress analysis is another way that Inventor differs from AutoCAD. This is a picture of a foundation under analysis. Even though when we were using AutoCAD, we were drawing in 3D and extracting a bill of materials, which was sort of automated. It was a very cumbersome process. Now, when we went to Inventor and SDS, we can produce intelligent, accurate model that carries over to the drawing, and the bill of materials that's connected with the model then becomes the parts list. So now everything is connected, and when a change is made in the model, it instantaneously updates the drawing and the parts list on the drawing. I'm going to show you this in the video. This is just a little example of how Inventor works. We have this patterning tool, which is one of my favorites because we do everything in threes. So we just set the distance by the axis, and we pick the amount and the spacing and click OK, and now we have our three phases. We also have the bill of materials, that is the information contained in each part for the assembly that was shown. And that we set a base view, as you can see here, place it on the paper, drag it down, and we've created our views. It's also populated our title block. We can add in dimensions very easily. This was a very tedious part with AutoCAD, but you can see here I just picked the tool, pick 2 points, and it's done. Ballooning is where it carries the intelligence. What you see here is placing the mark numbers, and it is what it is. There's very little checking that needs to be done. Then we will place a parts list, which is the way that we can display the bill of materials. And I want you to pay particular attention to these parts that are being highlighted. It's the breaker and 2 switches. I will show you how easy it is to change out a breaker and switches and the cabling. This is a job that we do constantly because of our aging equipment. I'm going to open up this subassembly, and now I'm going to show you the bill of materials with the assembly and the equipment that we're going to change out. The first thing is the L switch, and you can see I picked it out of the vault. The vault comes with Inventor, and it keeps track of where all the parts are. Now you see me changing all of the dual connectors out. SDS now has a new tool that will change all dual cabling. At the time that this was recorded, that new version was not out yet. But you can see how easy it is to change the cabling, and actually it will be easier. Now you can see in the bill of materials that the new equipment is installed, and I need to put the correct information for the mark number for the switches, and we will just replace the whole subassembly with the new subassembly. And we need to change a dimension, and you can also see that I have added the bushing numbers, which is helpful because we always place bushing 1 and 2 on A phase. And now you can see here in the parts list that immediately the new equipment has been added. I have 3 examples for the toolkit: cabling, conduit, and grounding. The toolkit does so much more than this, but for our time allowance here, I'm just going to show you those 3. Cabling. This is the way that we had to do our cabling in Inventor, which it was better than AutoCAD, but it was quite bulky. There I just constrained a terminal lug to the switch pad, and then I opened the cable and harness tool and saved the cable harness. Now I'm going to create the segment, which is just the path that the wire runs through, and you can see I'm picking points through the terminal lug, on the breaker, and now on the switch. That's finished. Now I have to create the wire, and the wire contains the information that goes in the bill of materials, such as our CU code, our mark number, description, and finally I have to route it. Now we will look at the SDS tool for cabling. It is part of their above grade tools, and I pick settings just to make sure that I'm using the cable that I want to use. Now I will pick bare cable fitting, and the only thing that I have to do here, there's no constraints, they're already programmed in, is to pick the switch pad and now pick the breaker pad. So there you go. The fittings have been placed. Now I just need to run the cable, and I do that by picking the fitting on the switch and the fitting on the breaker. Now we'll go on to conduit with the toolkit compared to Inventor. Here you see me picking the tube and pipe tool to create the run. And that's okay. I have to pick the hydraulic hose to get it to route the way that we're used to seeing our conduit. They do sweeps. Now I have to route it, and I have to pick a circular edge and another one. Here we go. On the handhole, and then I have to populate the route. Now we'll do it using the SDS below grade tool. I pick that, and then I pick an insert fitting, and this is our start fitting so that it'll know what size of conduit to run. And there are several ways to do this. Right now, I'm going to show you how we can use an elbow fitting and then change the constraints to get it to the distance that we need. There's two constraints to fix, and they both have to be equal. Now you can see that our elbow is placed where we want it, and we will create the conduit run from the breaker to the elbow just by picking the two circular edges. We'll reactivate the tool and do the same from the elbow to the handhole. And you can see that it's backwards at the elbow, but that's easily fixed. We can edit this cable, flip the starting point. Now grounding, we're going to generate a ground grid. Now we're adding the grid. This is set at a 10-foot grid, but this is just as an example. We need to run our grounding leads. The first thing we'll do is place the lug, and now we're placing the tap, and you see it's been done there. And now we'll actually run the lead, and we have several options to do this. So I'm going to use the interactive tool, and it allows me to pick points approximately a foot apart, and I can also change the distance. I have a good idea what our distances need to be, so that's what I'll do, and create the lead and done. And let's look at it from the top, mainly because that is the view that I'm going to use to create the construction drawing and send out to the crew. I hope that you have enjoyed this video, and if you have any questions, please go to automationforce.com, or you may contact me at thummel@nespower.com.